Hello, let's continue our Sudoku adventure with O like Orbit by Wuschel. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have region sum lines in the grid. So that's these blue lines here. What we do is we segment the lines whenever they cross a box boundary. So let me call this green, purple, orange, and blue. So each color represents a different segment here, just to demonstrate how that works. So as we move across the box border, we create a new segment. And so this is a segment of length 2, length 2, length 1, and length 1. And each segment on the same line have the same sum. So whatever goes in green also goes in blue, and then that's the sum of the oranges and also the sum of the purples. So that is the region sum lines. In addition to that, we do have two dots here, a white dot and a black dot. These are crop key. So white dots separate consecutive digits. So if this was a 2, this would be a 1 or a 3 in order for these to be consecutive. And black dots separate digits with a 1 to 2 ratio. So one of them has to be exactly double the other. So if this was a 2, this could be 1 because 2 is double 1, or it could be 4 because 4 is double 2. Order doesn't matter. We can also have 2, 4 here. There's no black dot. We could have 2, 3 here. There's no white dot. That's perfectly fine. We're not given all of the dots. It's just these dots are telling us about these specific cells. And that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so we know these are the same digit as each other. I'm going to actually use just green to represent that. We also know that these are the same digit as each other. I'm going to use purple, and we know that purple and green are different digits because they share a box here and share a box here. So the sum on this line is different than the sum on this line. Now, we are restricted in what it can be, because these are three different, these have to be 3 different digits. So the minimum I could put on these 3 digits is 1, 2, 3. And then I could also put a 1 here, and I would just remove 1 as a possibility there. So in this case, 1, 2, 3 adds to 6, plus another 1, that's 7. And these are 2 different segments of the same sum. So 7 divided by 2 is 3.5, which means actually 4 is our minimum sum. But I will say we can't actually do 4. So unfortunately, taking the addition there didn't help as much as I hoped, because 4 would require 1, 3. And then we'd also have to put a 1, 3 here, because there's only one way to add to 4 without repeating. And you can never repeat digits within a segment because they all always share a box. That's just how the segments work. And so we'd have too many 1, 3s in this column. We won't be able to spread them out across 3 cells. And so actually we are limited to just 5, 6. And so that's going to be true of both of these, which means, we're going to have 2 different sums here, right? So if this was 5, for example, we could have 1, 4 here. And because this sees a 1, 4 pair, we then have to do a 2, 3 pair here, or the other way around. And then if it's 6, there's also only 2 ways to add to 6, 1, 5, and 2, 4. But I don't know what to do with that at the moment. So we do have 5, 6 pair here, 5, 6 pair here. Is there anything I can say about... I mean, we know purple is in one of these 2, and then we know green is in one of these 2. If this was green, it would be consecutive with that, but that doesn't help me. Black dots can't have 5 on them. Maybe that's helpful. Don't know if it is. The one that adds to 6 is going to need a 5 somewhere. Like if these were 6s, we'd need a 1, 5 somewhere. So, okay, there's one thing I can say, and I don't know how helpful this is, but this can't be a 2, 3 here. Because if this was 2, 3, I'd have no way to fill the black dot. I can't do 1, 2. The 2 is used. I can't do 2, 4, and I can't do 3, 6. So 2, 3 is not going to happen here. But that doesn't really affect much, does it? It's either 1, 4, 1, 5, or 2, or 2, 4. So 1, 4, 1, 5, or 2, 4. So it's not 3 or 6. I don't think that's helpful, is it? 2, 4 would force this to be 3, 6. Oh, and that doesn't work. Okay. So if this was a 2, 4 pair, adding to 6, this would have to be a 6. And now I couldn't do 1, 2 here, I couldn't do 2, 4 here, and I couldn't do 3, 6 here, which are the only 3 ways to fill a black dot on a 6x6. So this can't be 2, 4. So we're down. So that means it does include a 1 because we're either 1, 4 adding to 5, which would force this to be 3, 6, and that's fine. Or we are 1, 5 adding to 6. We can't be 2, 4. We can't be 2, 3. Interesting. Okay. Excuse me. Wow. That means there is not a 1 here. Is that helpful? Let me think about 1, 4 here, because 1, 4 is definitely going to force this to be 3, 6. Well, we know green ends up here, so that's not really a problem, is it? That seems to work. 1, 4, this would be 5, this would be 3, 6. Is there something I'm missing about this? 1, 4 would then make this 2, 3. Which would make this 6, 3. And then 1, 5. The other way to add a 6 is 2, 4. So there's always a 2 in one of these two. Now, if this sees a 2, 4 pair, so 1 would be gone. 1 is always gone. This is never 1, 2. This is either 2, 4 or 3, 6. But, oh, so this is always 3, 6? Okay, let me double check that. But I think this is always 3, 6. So let me go through the cases. If this is 1, 4, that adds to 5. This would be 2, 3. So let me write it out for you. If this is a 1, 4 pair, this is a 2, 3 pair. The 5s don't matter, but these end up 5. I'll minimally mark this. So 1, 4 and 2, 3. So now what do we put here? Well, the 1 and 4 are gone, so we can't do 1, 2 or 2, 4. So we'd be 3, 6. So that forces this to be 3, 6, and that's fine. Okay, the other option here is that this is 1, 5 adding to 6. Oh, does that just not work then? Okay, well, let's think about it. If this is 1, 5, this is 2, 4. And now this cell, and then this is a 6. And so now, look what happens. This cell cannot be a 1, because there's a 1 in the 1, 5 pair. It can't be a 2 or a 4, and it can't be a 6. So this can't be 3, 6 at all, because it sees a 6 here. And so it would have to be from 1, 2, 4. But this 2, 4, the 1 that can't be used because of the 1 here, and then the 2, 4 can't be used because of the 2, 4 there. So it just doesn't work out. So we can't actually do 1, 5. We have to do, let me just write it out. We have to do 1, 4 with a 2, 3, and then these add to 5, which makes these add to 6. Okay, so there's a 5 in one of these two, there's a 6 in one of these two, and I don't need any of the colors anymore. Okay, now this adds to 6 and this adds to 6. So in general, they are from 1, 5, 2, 4, and the 5s take 5 out of both of these. So this has to be 2, 4, making this a 1, 5. Because again, if this was 2, 4 as well, we would have 3 2, 4s in the column. So this is 1, 5. All right, that is progress. That was kind of crazy. So now we know that 1 and 4 are gone. This has to be a 3, 6 pair. The 2, 3 pair tells us that's 6, that's 3. All right, I'm going to pause just a moment here. Okay, let's resume this. So what was I doing? Okay, I've got a pair here. So I need a 2, 5 here. So I got the 2, 4, I got the 1, 5. This 6 can't go here, because if this was 6, this would have to be 5, and that ruins the 1, 5 pair. So 6 ends up there. So this is a triple. This is 1, 3, 5. That's not a 5. So the 1 would force a 2 there. The 3 could be with 2 or 4. Let's see. There must be something obvious here. The 3, the 6s. We do have two 6s here. So there's a 6 over here. There's a 3 in one of these two cells. What else can I do here? This 6 looks up. This isn't 6 because of the black dot. Sorry, the white dot. So this is a 6. Places that 6. Okay, 6s are done. 5 is in one of these. So this is a triple. We need a 2, 3, 4, and the 3's in one of these, which then places the 3 here. That gives us the 1 and the 2, which gives us 3 and 2, which gives us 4 and 3. We get our 2 and our 4 here. We get our 5 and our 3. This top digit's a 2. This is a 1 to finish the column. That gives us 4 and 1 here. This finishes the box with a 4. All right, this cell here is, so for the row, we need 1, 5, and this 1 tells us the order. That's 5, that's 1, that's 5. We get a 2 and a 5 here. These two digits are 1 and 4. This 1 tells us the order. Again, we get a 3 there. This column finishes with a 1. We need a 2 and a 4. That's 2, that's 4, and we're done. All right, cool puzzle, Wuschel. I'm not going to talk about it much because Lily just started crying again. All right. Well, how'd you do? And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.